the Tidbinbilla Deep Space Tracking Centre just outside Canberra. It's one of 3 tracking stations used by the Deep Space Tracking Network in the world. There is one in Spain, one in Goldstone, California, and one here in Australia at Canberra. Radio telescopes are the means by which we can now trace the electrical nature of the universe, because they are able to measure the magnetic fields in deep space, and it has been found that these magnetic fields are strung between galaxies. They thread through galaxies and they surround the stars in galaxies. The idea of electrical activity in the cosmos flies in the face of cosmology, which relies on a gravitation-only model. This is despite the fact that NASA finds evidence day by day that gravity cannot explain. The electric force is 1,000 billion, 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 billion times stronger than gravity. Cosmology is supposed to be the queen of the sciences, yet its students are taught nothing about electrical activity in the universe. They go on to make the mistake of treating plasma like a heated gas, and they talk of the solar wind, for instance, and of shock fronts. Cosmologists need to rethink their ideas about gravity. If you look at our solar system, it's a complete fruit salad. The different characteristics of the planets, their tilts, their spins and their atmospheres, all belie the idea that this has been a natural progression from some simple beginning. And when NASA looks into deep space, we see things changing more rapidly than is expected on this kind of slow evolutionary picture. This belief in a Newtonian clockwork solar system, where what we see today in the skies you would have seen 4 billion years ago. But nothing could be further from the truth. The ancient skies would bear no resemblance at all to what we see today. In fact, I would guarantee that if any of us were transplanted back in time, if that were possible, that we would be frightened out of our wits.
Can you tell us something about what auroras that they saw, the aurora australis possibly? There may have been some other electrical phenomena in the sky. What sort of things do you think they might have been reporting about?
Well, it's interesting that you say that there are magnetic reversals found at the site, because that indicates a change in electrical currents. Basically, you don't get a magnetic field without an electric current.
Oh, that's a precursor too.
So that's, yeah, that's an indicator that we're looking at an electrical phenomenon. And when you talk about auroras, they of course are one of the grandest electrical phenomena that we see on Earth. And we know that auroras are connected with activity on the sun, but we do have very strong evidence now from research being done in modern plasma physics that around the world were witnessed auroras which were thousands of times more powerful than present-day aurora. And we can say that with fair certainty, because when you get that kind of energy, the plasma takes on forms which we don't see in the sky today, but which are very characteristic of what we see in plasma labs.
Oh, okay.
So the change in currents, the change in magnetic field could have been associated with these super powerful auroras. There have been peer-reviewed published papers on this phenomenon of super powerful auroras, so we're not just making this up, so to speak. And the way we can test this is by looking at the kind of imagery that not only the Aborigines but also all prehistoric peoples around the world recorded by chipping into stone or their artwork on rock.
These petroglyphs, I believe.
The petroglyphs, yeah. That's right. And the interesting thing is that we've found that the shapes, these weird shapes which have been interpreted as stick men or even as astronauts, you know, because of the strange helmet-like protuberances and horns and so on.
Virginia and...
That's right. The fact that we can tie these in now to these high-energy discharge phenomena in plasma labs means that it gives a very strong argument for the fact that the ancients witnessed not only the super powerful auroras, but lived through a time when something strange was going on in the solar system.
So you're saying, well, just to make sure I've got this right, that the shapes that they carved into rock resembled the shapes you're seeing in these plasma discharges in laboratories?
Yes, and the interesting thing is that as this high energy discharge takes place in the laboratory, the shape changes over time.
Right.
Very quickly in the laboratory, but if you consider something on the scale of the Earth or an aurora, it takes place over a more extended period of time. And some of the shapes were very distinctive. One of them is known as the squatter man.
Okay.
Which is a figure with the arms upraised like this at right angles and the legs also splayed at right angles.
Yeah.
And the strange thing is that almost without exception around the world you find that these dots are drawn between the elbow and the knee.
Yeah.
And this of course makes no sense according to the way we look at the world today. But in the plasma lab we find that this is precisely what you see. The figure with the arms, apparent arms upraised and the legs out at right angles, the plasma toroid, which is seen as two circles between the knees and the elbows, and also something that looks a bit like a head or a shape at the top.
So we've actually got photographs of this phenomenon in the laboratory.
Yes.
And tell me, well, the thing here is, with a magnetic reversal or whatever caused this electromagnetic aurora, what effects would be happening on Earth once it reaches a certain point? Perhaps you could tell us the certain point that it becomes, let's say, critical.
Okay, well, at those kinds of energies, when the discharge is that powerful...
And they do discharge.
Yeah, it is an electrical discharge. It's a cosmic discharge, if you like. The central part of this apparition generates X-rays, which can be lethal.
Yeah.
So that people would have recognised that this object in the sky had a profound effect on animals and themselves. And also, if the discharge to the ground was sufficiently powerful, you would get super lightning bolts, which are quite destructive and can actually sculpt the landscape to some extent.
So that actually tears Earth away from the landscape and pushes it up in the air? Or?
Yes.
Okay.
Yes. We've seen this in a small scale, where some super bolts have hit the ground and they carve channels, sinuous channels.
Yeah, I've seen one on golf courses.
Yes, that's right.
Yeah.
Yeah. Well, if you imagine that scaled up thousands, tens of thousands of times, you can imagine that whole river courses could have been sculpted in moments.
Okay. And even, I think you were showing me the other day what it does on interplanetary models, for instance Mars. You believe it carves out these craters, and you have some evidence of that sort of effect?
Yes, well, one of the features of electrical scarring is that it can form either sinuous patterns or it can form circular craters.
But that depends on what stage it's at? Or?
It depends on whether the Earth is acting as a positive electrode or a negative electrode.
Okay, anode or cathode.
But even today we can have what's called positive lightning or negative lightning, and the effects are different. This is something not many people understand, but the scarring or the cratering, the surface damage with the different charged surfaces, whether it's positive or negative, are different.
Okay.
And in the case of a negatively charged surface, what tends to happen is that the lightning or the arc strikes, creates a circular crater, and then it leaps, it hops about. And quite often it usually hops to the nearest high point. So what you find on the moon, for instance, is that you get the circular crater, a large one, and then perched on the rim at the high point is another circular crater, neatly cut into the rim of the larger crater.
Okay.
You never see the reverse. So this is sort of a characteristic of an electrical crater. And it's a puzzle that's been sort of pushed aside by astronomers and geologists, because there was a lot of argument 100 years ago about whether the craters on the moon were volcanic in origin, like a burst bubble, or whether they were impacts. And both sides had good arguments why it wasn't the other side's explanation. And finally it was up to a show of hands, and the impact people won, like so much of science.
But in fact you think there's very little evidence of meteorites actually finding bits of meteorites on?
They do not create craters like an electric crater.
Yeah, and these are flat bottom normally,
often
possibly
flat bottom with a melted surface, and often with terraces. And on the moon we do find some of the large craters with terraces, and the terrace itself has a melted surface, but the rock face beside it doesn't.
Okay.
Now you can't create that with an impact.
Now I'm thinking of some practical possibilities on Earth. I mean, I was thinking I was showing you the photos of the Carolina Bays in the US, where there's literally thousands of craters, different size, all next to each other, interface between river courses. Do you think that's possibly an electrical effect?
It could be. On the Moon, for instance, there are chains of craters.
Yeah.
And there is one in particular on the Moon, which is a chain of elongated elliptical craters.
Okay.
And so it could be that same kind of effect. The craters on the Moon are not caused by impacts or by volcanic activity.
Yeah.
And crater chaining is a characteristic of electrical discharge machining too.
And in fact, I think you've shown me pictures of studies done on metal, taking high voltage discharges onto the metal, and it does cause craters.
Yes.
It's very similar to what's on
Yes.
the Mars Moon. Now, just getting back to the sort of damage, what possibilities are there if we're seeing an aurora in the sky? What sort of things could cause it? No one actually knows, but there's some strong possibilities, you feel.
Well, one suggestion is, of course, that it could be due to an outburst from the sun, a particularly powerful one. And that is certainly one possibility. But the stories that I've seen from the people who've remembered and passed down the stories, like the Australian Aborigines, suggest otherwise. They suggest that there were large cometary bodies near the Earth at that time. And when you have two celestial bodies, particularly cometary bodies, moving through the solar system towards the sun or away from the sun, there is strong electrical discharge activity taking place on that body. That's what a comet is. It's an electric discharge phenomenon. It's got nothing to do with heating from the sun.
And I think you were one of the first to predict that when that, what probe was it that went to the comet?
The Deep Impact Probe, yes. When the experiment was announced, I suggested a number of things that they would discover which would be contrary to what was expected, and if the comet is just an inert rock travelling through the solar system. And the one which was spectacularly confirmed was the flash before the main outburst.
And what comet was that? That was
Tempel 1.
Tempel 1, and that was an American probe.
Yes, there was a copper projectile about the size of a washing machine that was fired in the path of the comet. And the comet was travelling at a huge speed, much faster than a bullet. And so when it encountered the copper projectile, they expected there to be a mechanical explosion. And
in fact it was discharged between the two.
Well, what was expected was that the copper projectile would strike the surface, there would be an outburst of material which they could then analyse, and also they could measure the size of the crater to give them some idea of the strength of the comet nucleus.
Right.
Because this is a bit of a puzzle at present. And I suggested that the flash would be far more powerful than they expected, and in particular that there would be a brief lightning flash between the copper projectile and the comet nucleus before it actually hit the nucleus. And that's precisely what was observed.
Okay, so let's take another case, one we know a fair bit about. Shoemaker-Levy 9, the comet that actually went towards Jupiter, and before it did, it split unexpectedly, but they found that happens a bit more, into, I think it was 23 segments. Each one of those headed down and discharged well above the surface of Jupiter, and that electrical discharge impacted and left huge effects on the surface of the planet. Is this the sort of thing that possibly could have happened as well?
Yes. With the charged body approaching the Earth, the first thing that will happen once the body gets close enough, reaches the ionosphere, for instance, 100 kilometres above, or even beyond, the two bodies see each other electrically, and all of a sudden there is an opportunity for electrical breakdown or a lightning discharge. And there's a Russian geologist who has published papers suggesting that this is what occurred with Tunguska.
Okay, now Tunguska, for those that don't know, was I think 1912-ish, 1908, and that was a huge explosion above Siberia that left an impact devastated area, about 1,000
area,
kilometres.
but no impact.
There's no crater,
Exactly.
but every tree was blasted away, and
Yes.
to this day everyone's scratching their head what happened.
And the thing that the descriptions of it were that it was brilliant, and there was some talk of discharges from the Earth to the object.
Okay, the other way around.
Yes.
Yeah.
And this is the kind of thing you'd expect, so that instead of having a mechanical impact, as was expected with Comet Tempel 1,
Yeah.
it's an electrical phenomenon first and foremost.
Right.
And that electrical discharge is sufficient in many cases to disrupt the incoming object, so that instead of having a solid rock hitting you, you have a shower of sand and debris, smaller pieces,
Okay, now,
striking an area.
in regard to this, I was talking to Ted Bryant from Wollongong University, the geologist, and he was talking about the Rick Firestone thoughts on this, in that whatever caused a devastating scenario in America and wiped out the megafauna there, apparently left them indented with little minute bits of hematite and carbon embedded right in them, and there was also associated with that, I think, high iridium levels, which apparently are being found at Lake Mungo. So I'm wondering, this possibly could be the sort of thing, as it discharged well above the atmosphere,
Yes.
or it went back up. Lots of, let's say, effects of minute particles.
Well, that's one of the other things that's never taken into account in geological textbooks, and that is that if you get a sufficiently powerful electric discharge, then you actually can cause nuclear transmutations.
Yep.
So you can generate...
Or uranium to lead. And
yeah, well, no, you can go the other way. You can
Yep.
create heavy elements from lighter elements, and radioactive elements from non-radioactive elements. And because we do this as a matter of course in particle accelerators,
Yeah,
you know,
yeah.
where you use a lot of electrical energy and you come out with new matter, new particles. And so the iridium layers and other decay products from nuclear fusion or fission are expected when you have these kind of very energetic electrical events.
And of course, when cosmic rays hit the Earth, they convert perhaps normal nitrogen to the isotope carbon-14, oxygen-18. This is part of the normal process involved, but when you're getting these big auroras, there's going to be more cosmic rays coming down, correct me if I'm wrong, and theoretically you're going to be forming more isotopes of many materials, I assume.
Yes. One of the mistakes that geologists make is to treat the Earth as a closed system for millions or billions of years, and in fact all of the evidence that we can amass from this new view of the solar system shows that's incorrect. That at many times the Earth has encountered both matter, material from space, and also electrical interference from space. And both of those things, once they're taken into account, will change our picture of not only the history of the Earth, but also the more recent history of mankind. And it's people like the Australian Aborigines who have something very useful to tell us about our science.
Yeah. I was at White Cliffs the other day, the opal place, and there's big caves they've mined down there. And one of the things I was noticing about the walls, there's these huge, they look like tentacles coming upwards through the rock strata, and obviously changing the rock to much darker colours. Is that explainable by electrical magnetic theory?
Yes, it is. One of the things that come out of this work about the electric universe is that every celestial body behaves like an electret. An electret is a body which is normally charged. You know, it has a charge stress inside it.
Yeah.
If you get a strong discharge from space, either from the sun or from an intruder, then one of the effects is that you may get auroras and lightning, but you'll also get discharges from within the body seeking the surface charge, seeking to neutralise it.
Okay.
And in doing that, you get earthquakes, because an earthquake is really subterranean lightning, if you like.
Yeah, I think we discussed thunder and lightning, but
That's
under
right.
the ground.
Yes.
Yeah.
And there are two slow forms of discharge too. One is a tornado, where the discharge is constrained to take place more slowly, and quite devastatingly, because the charge is circulating at high speed, and so the magnetic forces are immense and constrain the whole thing within that funnel. In the Earth, it appears that you can get slow discharges which can actually cause volcanoes, and volcanoes have some of the most spectacular lightning displays known to modern man.
Yes, I've seen pictures of some of those.
So there is an electrical connection not only between space and the ionosphere and our weather and the surface of the Earth through lightning and tornadoes, but also within the Earth, because the Earth itself is charged.
And I believe the sunspots often have a time with earthquakes, because during the sunspot it's a time of minimum more, I think, isn't it? Where the earthquakes are more, or it might be the other way around, I forgot.
Well, it's recently been discovered that a preceding signal of a major earthquake is a sudden inrush of electrons into the ionosphere above that area where the earthquake is about to occur. So there is a lot of work being done by some people now to try and use satellite technology, and also just bouncing radio signals off the ionospheric layers to detect these changes over a broad area, to alert people to the fact that we should be prepared for a major earthquake.
And this again is an electrical effect from the sun?
It's an external electrical effect upon the Earth.
But we're not really sure.
In modern times, of course, the sun is the most active electrical body in the solar system.
Yeah, and that's not necessarily always been so. But,
no.
But in simplicity, the Earth and the sun have a giant interconnection electromagnetically, and they interact during different phases. Just getting back to the sun now, as we know, it reverses its polarity every 11 years and roughly. And the sunspot cycle is from maximum to minimum, what, 22 years, something like that. Is there any explanation for this changing of polarity? I mean, or is it all theory-laden stuff?
There's just a hypothesis that there's an internal dynamo, but no one's been able to show exactly how this works, and the observations tend to suggest that that's not the case. The answer is very simple if you treat the sun itself as an electrical discharge phenomenon, and that is the simplest possible model that you can propose, because it doesn't require any thinking at all about what's going on inside the sun. You can ignore that. What you're looking at is in effect like a giant ball of lightning, and so when you have the electric current required to make the sun shine, you have to have a circuit. It can't be just a one-way current in, and then, because otherwise the current would persist for a short time, and then the sun would wink out, and that doesn't happen. So it's a part of a circuit, and the Nobel Prize-winning plasma physicist Hans Halfvén, the Swedish Nobel Prize winner, has actually drawn the circuit diagram for the sun.
Oh, okay, yeah. Something as big and huge as that.
Exactly, and the current flows in at the poles and out at the equator, but in getting from the poles to the equator it has to flow over the surface, and it does that in such a way that it generates magnetic fields near the surface of the sun, and the sun then acts in some ways like a transformer, only in a varying direct current circuit. In other words, the current never changes direction, but it varies in strength, and as it varies in strength, the magnetic field switches from one direction to the other.
Right.
And that creates the cycle. It's very simple, really. Any electrical engineer can understand that in a moment.
And I think Donald Scott, I was reading some of his stuff, believes that you don't have to have an entire magnetic reversal. One of the side electric currents can change direction within the whole flux, or have I got that wrong?
Well, it can, in detail, it can become quite complex, but overall it's a fairly simple picture. It's interesting because then it shows that the power supply for the sun itself has a cyclic nature to it.
Yeah.
Like most things we discover, there's a cyclic nature to it.
Yeah. Well, I guess coming back to the Earth, I mean, that's also an electromagnetic body. So when it changes, could it be due to some internal flux, or is it obviously related to some
No, I think when
comets?
you get magnetic reversals, and in the case of Lake Mungo, I believe the reversal was fairly rapid, and also the magnetic field strength was stronger than it is today.
Yeah, about 10 times, I believe.
Yeah. Well, in those cases, I would suggest that what is happening is that locally there is a lot of current flowing through the ground, if you like.
Yeah.
And the direction of that current is such that the magnetic field is a different direction to normal. But I don't consider it to have been a sustained situation.
Now, as you know, Wal, I think it was Hutton and Lyell in around about the 1850s introduced a new concept in geology, that essentially everything we see today, the erosion of valleys, hills, the slow sedimentation, these are the only things that are needed to explain everything that's happened on Earth, and it's taken thus millions of years for these slow processes to work. How does the electric universe change this model?
Well, the electric universe says that with the close approach of celestial bodies, there is charge exchange. In other words, thunderbolts of the gods, if you like.
Yeah.
And they are of such incredible power that they can carve valley systems, they can raise mountain blisters, they can sculpt the landscape in a matter of hours. And if you think about it, one of the examples of this could be that some moons, for instance, have one side which is looks different to another.
Oh, yeah.
Even Mars has two hemispheres which are different. Now, if two bodies approach one another, of course, it's the hemispheres that are adjacent which will suffer the scarring preferentially.
Right.
Because it happens in such a short space of time, the bodies don't have time to rotate very far. So the evidence from looking at other bodies in the solar system is that this kind of thing has happened in the past and has sculpted a planet or a moon's surface in a very short period.
Okay, a short period. This is the essence, though,
that's
isn't
right,
it?
yeah. So it's quite different. It gets back to the predominant paradigm before Lyell and Hutton, and that is of the catastrophists like Georges Cuvier and so on, who said you've only got to turn over a spadeful of earth to see that the earth has suffered catastrophes in the past.
So we're saying here essentially something like the African Rift Valley could have been caused or happened very quickly. It wasn't a process taking millions of years.
Yes, there's two effects, of course, if you've got the close approach of two bodies. One is the surface sculpting by electric machining. The other one is, of course, the tectonic movements because of the intense changes in gravitational force and so on, which can cause rifting and faulting and that kind of thing, and the raising of mountain ranges and so on.
So a mountain range will be dragged out of the earth, so to speak.
Yes, there's two aspects to that as well. One is that a certain kind of arc will raise a giant blister, so you'll get something like the gigantic Olympus Mons on Mars, which is called a volcano, but if you look at it, it doesn't have the lava flows you'd expect from a volcano, and the summit is punctuated by a series of huge circular craters superimposed one on top of the other.
Yeah.
And it's typical with a lightning bolt for it to be a series of pulses.
Okay.
So that you get, it's not just a single discharge, it will zap the same spot repeatedly. And on Mars you can see that on the top of Olympus Mons, there are these superimposed circular scars. They would have occurred in a very short period of time, probably measured in minutes.
Oh, right, right.
So this gives you the extreme opposite idea that these things take thousands or millions of years to form.
Right. I mean, we were talking about the Grand Canyon the other day, and it's quite feasible that features like this with incredible depths of carved out channels could have been created this way. And I mean, a lot of Aboriginal mythology says how the rivers were actually created by a cosmic snake. Much as that sounds fantastic, this could have been their emulation of how the rivers were created.
This is your snake.
Yes. Yeah, so moving up and carving out great
yes,
channels.
that's right. And creating water holes and so on.
Yes, they
dotted around the countryside.
Yeah, well, there's lots of the mythology. I was talking to a chap from the Barkinji tribe today, and he was very big on that the water holes were created by, I think it was some sort of bird.
Mm-hmm.
And so it's quite, it sounds like a load of rubbish basically, but
yeah,
that's actually how they describe it.
One of the plasma forms that we mentioned in another discussion was the squatter man.
Yeah.
But one of the other figures that you see quite often in petroglyphs is the like a squatter man with a head is a duck.
Yes,
duck shape,
yes,
bird
I've
shape.
seen that. Yes.
Yeah, so that that's a common motif, is the dove or the bird associated with this plasma column.
Yeah, this Barkinji elder was talking about a willy wagtail moving along and creating these water holes.
You can imagine the darting movements of a willy
wagtail
could be a good description of it.
Yeah, amazing.
Yeah, you know, the reason why we consider God to be in his heaven, all the gods were in the heavens, heavens, and their behaviour was capricious. It was devastating at times, and at other times it was amazingly beautiful, and just it etched itself into human memory, it seems.
And this has not been a single occurrence. This has happened a number of times, and this is coming back, if you like, to the other aspect of geology. That it's just not been one event or one discharge. It's been a number creating different systems of mountains, rivers all over the world.
All of the great dyings, as they call them, when the living forms on the earth were decimated, and then new creatures sprang up in a different environment. The environment must have been different to have created all of the changes we see in the fossil record. It also explains why the fossil record is discontinuous.
Well, as Cuvier points that out, as you're right to say that it suddenly ended.
Yes.
And there was a new generation or creation. We hate to use that word because we get labelled creationists, I think. But that's actually what happened. The fossil record comes to an end, and a new genre of animal life begins on Earth.
Yes. When we talk about creation, it's interesting that our preconceptions get in the way of understanding what was actually meant by creation. All of the ancient races around the world viewed it as the creation of things in the heavens. And in fact, the original word for earth meant what they saw being created in the sky. And because it was so close, it was so overwhelming almost for the human to witness, it has come down to us, and we've sort of tried to put that into our modern day experience, and it just doesn't work.
Yeah.
It means that the mistranslations and the misunderstandings are legion in our creation myths.
Yeah, well, in one way we can understand Hutton and Lyle because they'd seen, let's say, 1,000 years of relatively peaceful human history, despite obviously there had been droughts, famines and decays of civilizations, but nothing like it had perhaps occurred 2,000 years ago.
Yes, yes. We just have no conception of what the people saw. But we do have the opportunity now, based on images from deep space where we do see violent events taking place, to recreate, using modern computer technology, what the ancients saw and give us some idea of our actual past on this planet.
Well, what about? I mean, today on Io, you can actually see Jupiter.
That's right.
Causing effects on its nearby moon.
Yeah, I've called Io a living laboratory for electrical machining of a body's surface, because the so-called volcanoes on Io are not volcanoes; they're electric discharge points on the surface of the.
And actually, the whole mountain moves around on the surface of Io, doesn't it?
Well, the volcanoes, so-called volcanoes, move 100 kilometres in a period of a few years. Well, what volcano on Earth does that?
Yeah.
And it's just a moving discharge.
All right, well, thanks. I love that plasma.